So in 11.4, we take system of equations, and using the elimination method, now we're going to combine one other factor, and that is multiplication. So let's, to prepare our minds for what we'll be doing, let's take a look at what happens when we multiply a particular linear equation by 3. So if I take this line, 2y minus 4x is equal to 8, and I multiply both sides by 3. You could pick any number, and this will still be true. If I multiply both sides by 3, and you'll see what I mean in a moment, 3 times 2y, 6y, 3 times negative 4x, negative 12x, all that is equal to 24. 8 times 3 is 24. And now I want you to take this new equation here and put it right here. 6y minus 12x equals 24. And we're doing this to illustrate a point that you need to be able to observe firsthand. Now I'm going to take, on column B, I'm going to solve for y. And above this one, I'm going to solve for y. So let's see, if I solve for y, on this side, I have to add 4x to each side. When I do that, I get 2y is equal to 4x plus 8. From here, I have to divide everything by 2. When I do that, I get y is equal to 2x plus 4. And you're like, so what? But let's take a look at the second part of example B. Let's also solve for y. Here I'd have to add 12x to each side. When I do that, I get 6y is equal to 24 plus 12x. And from here, I have to divide everything by 6. When I do that, I get y is equal to 24 divided by 6. 4, 12x divided by 6, 2x. As you can see, this and that are the same thing. So by me multiplying this by 3, it really didn't change the equation in any way other than increase it by a factor of 3. And the point you're supposed to be able to see is that you can manipulate these equations so that you can get something to eliminate by multiplying one of the two lines. Sometimes even both of the lines, as more examples will become evident. Now I don't think we need another example of this. Let's go immediately to the next page. And so for solving systems of linear systems by multiplying first, you have to decide which variable you're going to eliminate. You have to multiply one or both of the equations by a constant. That simply means, multiply them by a number. It's the same number on both sides. So that adding or subtracting the equations will eliminate. We'll eliminate the variable. Then solve the system using the elimination method. And let's take a look at this in practice. If I have 5x minus 2y equals 11, 3x plus 5y equals 19, I'm going to have to multiply it looks like both of these equations in order to solve. So I have to pick. If I want to get rid of the x's, I have to find a common number that both 5 and 3 go into. If I want to eliminate the y's, I have to find a common number that both 5 and 2 go into. I think I'm going to pick the y's to eliminate. And let's see, I'm going to do that by, if I have 5x minus 2y equals 11, and 3x plus 5y equals 19. And I pick the y's to eliminate. Basically, I'm going to multiply. The thing that comes to mind is for 2 and 5 is the number 10. They both go into 10. So I'm going to multiply this top equation, both sides, by 5. That's going to get a negative 10y eventually on the top. This bottom equation, to get to a positive 10y, I'm going to have to multiply everything by 2. When I do that, I'm going to rewrite my equations here. 5, and I'm going to rewrite the new equations for the purposes of elimination in purple. 5 times 5x, 25x. Right? I'm just carrying out this multiplication here. 5 times a negative 2y, negative 10y. 5 times 11 is 55. Now in, let's say, green, I'm going to carry out this multiplication. 2 times 3x, 6x. 2 times 5y, plus 10y. 2 times 19, 38. Now I have something that will eliminate. I can add these two equations together. These will cancel. 25 plus 6 is 31x. And 31x is equal to 55 plus 38, which is 93. And then I divide both sides by 31. X winds up being 3. Now, that we know that x is equal to 3, let's plug in to one of the original equations. How about let's pick this one, 5x minus 2y equals 11. So we know the value of x is 3. Substitute for x the value of 3. Minus 2y is equal to 11. 15 minus 2y is equal to 11. Minus 15 minus 15. You get minus 2y is equal to minus 4. Divide by a negative 2. Y is equal to positive 2. So the solution here is 2, 3, 2. And you can graph that, or you can confirm this by graphing these two lines as well. The graph of these lines, I'm going to put them into y equals mx plus b format. 5x minus 2y equals 11. You're going to get basically 2y is equal to 5x minus 11. You'll divide both sides by 2. You'll get one side, y is equal to 5 halves, x minus 11 halves. And then the other one, you're going to get y is equal to, should say 5y is equal to minus 3x plus 19. Divide both sides by 5. That one is a graph of y is equal to negative 3/5 x plus 19/5. Oh, what a mess. Bunch of fractions. Well, we're not going to bother graphing those, but the point is these are going to meet at 3, 2. 1, 2, 3, 2. That's the point where the two lines are going to intersect. And let's see. From here, let's try another example. Here I've got 3x. I'm moving on to the second example here. 3x plus 4y equals 13. 2x minus 2y is equal to negative 10. Hopefully you can recognize 2 and 4. They're multiples of each other. If I just take this one equation here, multiply both sides by 2, I'll have something I can eliminate. So let's rewrite this. The top equation, 4x plus 4y equals 13. And let's put the rewritten one here. 2 times a 2x, 4x. 2 times a negative 2y, negative 4y, 2 times, is it a positive 10 or negative 10? I can't tell anymore. Oh, it was negative. 2 times a negative 10, negative 20. Now I can add this together. 3 plus 4, 7x. This will cancel. Minus 20 and plus 13, minus 7. Divide by 7, x is equal to negative 1. Now that I know what x is equal to, I can plug it in here. 3x plus 4y equals 13. I'm substituting for x the value of negative 1. 3 times the negative 1, negative 3, plus 4y equals 13. Minus 3, oh, keep doing that. See, minus 3, plus 3 to both sides. 4y, taking the work now over here, is equal to 16, which is 13 plus 3. Divide both sides by 4. Y is equal to 4. So I have a solution of negative 1, 4. I don't know. I think the elimination method is not so bad. I hope you agree.